AP FTC, one of my favorite types of AP problems. So the key thing with this is this, guys. They give you the graph of f. So that's AP FTC problem. They'll give you the graph of f. And they'll say something to the effect of, let g be this function that integrates f. So with this, you gotta keep in mind that integration to area. I think it helps when you write area. I always do this, and I say, okay, if I take a derivative of this, that's gonna cancel out. You just get f of t. That's just a point. If I take the second derivative, I'm gonna get f prime of t, and that's the slope. So the original is area, then you get the points, it's the value, and then you get the slope. The only time it gets tricky with that, other than that, for that stuff, by the way, it's just they'll ask you basic questions. You just gotta know your definitions. You gotta know that thing, right? G prime tells you when it's increasing, decreasing. When G prime equals 0 or undefined, very important on this guy, that's when you have a critical point. And the second derivative second derivative tells you concave up, concave down. When it's second derivative equal to 0 or undefined, then it's an inflection point. Right? You gotta know all the basics. But that's what all this stuff tells you. The only time it gets tricky is when it's like this, when they flip it on you. So you gotta keep in mind, if I'm gonna take a derivative, so that's still h of x is fine. You just take the area from x to 3. But they ask you to find h prime of x. You can't take a derivative like that. First, you gotta rewrite it. You gotta flip it top. So it's be negative 3 to x of f of x. So when you take a derivative and they cancel out, you get negative f of x. So you gotta keep that in mind. So if you see the x on the bottom, you have to flip it. Other than that, that's a normal FTC. Let's do a couple problems. So from 2003, Form B. Let the function be defined above on 0 to 7. The graph of x consists of line segments shown. Let g be the function given by that. So again, that's my area. So again, I always do this. I always write, okay, that's my area. I'm gonna put g of x, put it right here. Equals integral from 2 to x. F of x is my area. Then g prime is just f of f, that's a point or value. And g double prime is gonna be f prime, so that's gonna be the slope. Look for the slope there. So A, we want to find g of 3. So g of 3, just plug in 3. So it's the integral of 2 to 3, from 2 to 3. And again, that's this area. So we're going to find the area from 2 to 3. So the little trapezoid there, you can do the math on it. 1/2 height base 1 plus base 2. Remember the height of the bases are the parallel sides. So these are my bases. So it looks like 4 and 2. Height's this guy, so 1. So in this case, I'd get 6 divided by 2, I get 3. They want g prime of 3. So g prime of 3, use my little code right here. That's just f of 3. The value at 3 on f is 2. Done. And then they want g double prime of 3. Again, use my little decoder. It's f prime of 3. So that's just the slope at 3. Slope at 3 is going to do the slope. So what's going on here? It's going down 4 and over 2. So 4 over 2, negative 2. Right, so it went down 4 over 2, rise over run. And that's A. Just got to use the graph. B. So B, find the average rate of change. Remember, average rate of change is code for slope. So we're just going to find the slope from 0 to 3. So average rate of change, just the slope. So we're going to find g of 3 minus g of 0 over 3 minus 0. That is it. Average change is the slope. Now g of 3 is the integral from 0 to 3 of f. And g of 0 is the integral from 0 to 2, 0 to 0 actually, of, oh, my mistake. There we go. We're going from 2 to 3, sorry. That's my function. So integral from 2 to 3 of f minus integral from 2 to 0 of f, all over 3. Now 2 to 3 we did already. That is just 3. I have not done 2 to 0. Now keep in mind 2 to 0 is going the wrong direction. Right, you should be going from 0 to 2 of f of x. So that means that we have to flip it and make it negative. So whatever area I get right there, I'm going to make it negative. So from 0 to 2, that's just a triangle, where this is 4, and that's 2. So that's 8 divided by 2 is 4. So this is negative 4. Right, so again, you have to flip the limits. So I made it negative. The area I found there was 4. So negative 4. So this becomes 3 minus negative 4 over 3, which is 7 over 3. Done. C. how many values in C were from 0 to 3 is G prime equal to the average rate of change found in part B? Explain your reasoning. So for how many values C, where C is between 0 and 3, is G prime equal to the average rate found there? So let's talk about what G prime is, right? So G prime of C is just equal to F of C, right? Use my decoder. So it's just a value, the point F of C. They want to know where that equals 7/3. So basically, essentially, we're saying where does y equal 7/3? That's all it's saying. Let's go 7/3. 7/3 is like 2 point something. Draw a line. Hopefully a straight line. So 7/3 is, so it happens at 2 spots. So that happens at 2 spots. And I explain my reason, I'd probably I'd show the picture. And that's like, hey, it's essentially where f of c equals 3 and that happens at 2 spots. Like that should suffice. D. For the x-coordinate on each point of inflection on the graph. Find the x-coordinate of each point of inflection on the graph on interval 0 to 7. Justify your answer. So you want the inflection points. Now remember, the inflection points are where the second derivative of x equals 0 or undefined, and you need a sign change. Very important. Specifically in AP FTC, this last part is very important. So remember, go with my decoder. It's where f prime, the slope, so it's where f prime of x equals 0 or undefined, the sign change. So we're looking where the slope is 0 or undefined. So the slope is undefined here at 2, undefined here at 4, is like a little cusp, a little tiny one, and undefined at 5. So I'm undefined at 2, 4, and 5. Now we gotta check the sign change. Now remember, our sign change here, we're talking about slope, right? F prime is slope. So sign change is more of a slope change. So the slope does change here. It goes from positive to negative. Slope does not change there. Negative, negative. And slope does change there. So my only answers are 2 and 5. And your reasoning, right? Slope goes from positive to negative. And here the slope goes from negative to positive. There you go. That one's done. Let's do this next one. The graph of function f consisting of 3 line segments is above. Let g of x equals that. So again, I always like to do this myself. I go, okay, g of x equals the integral from 1 to x of f. That's area. G prime equals just f of x. So that's a point. And g double prime is equal to f prime of x. That's a slope. So let's do this. Let's do compute g of 4. So again, g of 4, just plug it in. So g of 4, you have an equation, just plug it in. 1 to 4 of a t. So we're just going to find the area from 1 to 4. So you find the area from 1 to 4. Oh, that's kind of a pain. You're going to probably do a trapezoid. And that triangle, and then that other triangle. It looks like these triangles cancel out, so it's really just that trapezoid. I'll do it real quick. That's 4 and 1, so 5 divided by 2 is 5 over 2. Times the height, which is 1. So 5 over 2. Then g of negative 2. So I'm going to do g of negative 2 also. So again, you just plug it in. So it goes from 1 to negative 2 of x. Notice that's going the wrong direction, so you got to flip your limit. So negative 2 to 1 of f of x. So that's just that triangle there. So that's what? 3 and 4, so 12. So divided by 2 is 6. So this is 6, and then half of that is, make that negative, so negative 6. B. Find instantaneous rate of change. So I just want the derivative of g with respect to x at x equals 1. So again, instantaneous rate of change, just derivative. So let's take the derivative of g. Look at your decoder. So g is just f of x, so we're just doing f of x. Now I want it at 1. So f of 1. F of 1 is just 4. Done. Find the absolute minimum value of g on the closed interval negative 2 to 4. Justify your answer. Oh, one of these. Remember, absolute min never changes, guys. Critical points plus endpoints. So for C, my endpoints are negative 2 and 4. My critical points is where the derivative equals 0. My derivative is f of x, so where f of x equals 0, which is at 3. So those are my endpoints, that's my critical points. Once you find those, you plug it back into the original function. In this case, that is g of x. So we're going to define g of negative 2, which we did already, so negative 6, how lucky. G of 4, which we already did, is 5/2, how lucky, or more planned. And we got to do g of 3 ourselves. Well, we did all of them ourselves, but currently. So g of 3, just plug it into the equation, 1 to 3. I'm going to find the area from 1 to 3 of f of x. Probably should write f of x so we know. So from 1 to 3, it's that trapezoid, which was 5/2, plus that little area of that little triangle, which is like 1/2, I think. Yeah, 1/2. So you could literally just write 5/2 plus 1/2. Or you could say 5/2 plus another triangle, positive triangle, so this has to be the max. I'll just put 6/2, which is 3. So my max is 3 at x equals 3. Find the absolute min. So that, again, they don't want the absolute min. I should read the question. Absolute min is negative 6. I should read the question. Because that's actually not a min, that's a max, positive, negative. So I didn't need to check that one. It helps you read the question, people. The second derivative of g is not defined at x equals 1 and x equals 2. How many of these values of the x coordinate of points of inflection on the graph justify our answer? So they're saying, hey, which one of these, of the points they give you, so all they're saying is they gave you 2 points, 1 and 2. They're saying one of these is an inflection point. Or how many of these are inflection points? Are they both inflection points? That's what it's asking. They're saying, hey, these are, the second derivative is not defined, so that means it's an inflection point. Which one of these is an inflection point? So man, we need a sign change, right? It's when the slope does not exist, so here and here. We need a sign change also. So at 1, you go from positive to negative, so that counts. At 2, you do not. So only 1 is inflection point. X equals 1 is an inflection point because it goes from positive to negative slope. And that's it. Let's do one more to make sure we got this. So here, let f be continuous on the negative 4 to 3, whose graph consists of 3 line segments and a semicircle in the origin. Let g be the function that gives us that. And again, I don't care. I do it every single time. G of x equals this is the area. G prime of x equals just f is the point. And g double prime of x equals f prime, which is the slope. Find the values of g and g negative 2. So g of 2, we're just going to integrate from, was it 1 to 2 of f? So again, integral from 1 to 2 is this triangle, so you find it, it's going to be negative 1, 2 times 1, yeah, negative 1. G of negative 2, plug it in, you're going to go from 1 to negative 2. That's going the wrong direction, so you got to flip it. So integral from negative 2 to 1 of f. Negative 2 to 1, oh, that kind of sucks. It is this triangle with that half semicircle. So that triangle is 3 and 1. It's like 3 halves. Plus, by the way, guys, this is all negative because of that guy. That circle there, it's half a circle, so pi r squared divided by 2, and its radius is 1. And it's below the x-axis, that's a negative pi r squared divided by 2, so that's pi over 2. So that's the answer. Or if you want to make it a little nicer, negative 3 halves plus pi over 2. That's all it's up, right? It was a negative on the outside because you had to flip it, and then that circle is negative because it's below the x-axis, that's positive because it's above it. So there you go. That's A. B, find g prime of negative 3. Well, again, use your little decoder up there. That's this f of negative 3. F of negative 3. So a negative 3. It's right there. Oh, that sucks. So, 1, 2, 3. Here's negative 3. So, you don't have negative 3. So, you have two choices. Now, that happens to be halfway between these two. So, you just do the midpoint. You can just go negative 2 plus negative 4 is halfway between them is negative 3. So halfway between 1 and 3 is 2. So that's going to be negative 3 and 2. Because it's the midpoint between those two, so you can just find it. If not, you can also just find the equation of a line, y minus y1, and x minus x1. And then find it that way. Like find the slope, plug in a point, and then plug in the point you need, negative 3. So both ways to find it. In this case, we got lucky. It is just the midpoint, so you just find the midpoint between those two. So it is 2. F of 3 is 2. They're jerks sometimes. Not giving the value right there. G prime with negative 3. So g prime of negative 3. If you look at your decoder, it's f prime of negative 3. So we're looking for the slope at negative 3. So we got to find, so right there, just do rise over run. If you need to do it earlier to try to find that. So you get 2 and then up 2. So 1. So it's just 1. So that's B. C, find the x-coordinate of each point of the graph which has a horizontal tangent line of each of these points to determine whether G is relative to min or relative to max, neither max, blah, blah, blah. So for C, they basically, remember horizontal tangent line is code for the derivative equals 0. That's what it's code for. Horizontal tangent line is when the derivative equals 0. So now our derivative, right, look at our decoder, is f. So when does f equal 0? Right, derivative equals 0 means when does f equal 0, and that happens here and here. They want to know if it's a min, a max, or neither. Now this one goes from positive. Let's erase that. It's a little messy. Right. So they're right here. That's my min. That's nothing. Sorry, those are my zeros. So that goes from positive to negative, so that is a max. This goes from negative to negative, so that's neither to neither if that doesn't change signs. So that's what I got. So at x equals negative 1, it's a max. You gotta say because it goes from positive to negative. And at x equals 1, it's neither. Because it goes from negative to negative. So that's C. One last one. D, from negative 3, final values when the graph has a point of inflection, explain your reasoning. So remember, point of inflection, again, you just gotta know your definitions. Point of inflection is when the second derivative equals 0. So in our case, according to our thing up here, it's when the slope equals 0, or undefined. Or undefined. Plus sign change. Very important things I forgot. So we're looking for where the derivative of x is 0 or undefined with sign change. So again, derivative means slope. So we're looking for the slope. It's undefined, right? Needs a sign change. So it's undefined right here. And it does change signs. It goes from positive to negative. It's undefined right there. It's kind of hard to see because I cursed over it. And that doesn't change signs. I know it does. It's plus and minus, but it doesn't change slopes, right? So we're talking about the slope here. So slope does change. It goes from positive slope to negative slope. Slope does not change there. And then right here, it actually does change slopes. It goes from positive to negative. So it ends at 1 and at negative 2 because of slope change. So it's to be at x equals 1 because it changes slopes. And at x equals negative 2 because it changes slopes. And I actually forgot one. At 0. Remember, it's 0 undefined. There's a 0 right there. And it does change signs. Slopes. Negative, positive. So there's actually 3. I missed one. X equals 0. Because slope changed from negative to positive. I was thinking, because like, how do you get 2 positive without a negative positive? And that's because I'm an idiot and I missed one. So there you are, right? So where's the inflection point? When the second derivative equals 0, my second derivative is my slope. So you're looking for the slope is 0 and undefined, and it has to change slopes. So it changes slopes there, and there, and there. And that's AP FTC.